Okay, today I'd like to talk to you about oxidation numbers. Um, Oxidation numbers, the way we get them is by using the groups, the rows that go vertical on the periodic table. Those groups, 1, 2, groups 3, 4, 5, 6, 7, and 8. Not the groups 3 through 12, what we call the transitional elements. Only those groups will give us the valence electrons in the um, in that particular element or atom. So if we were talking about lithium, for example, is in group 1. It has one valence electron. If you're talking about beryllium, beryllium is Be. It is in group 2 and has two valence electrons. And then we jump over to group 13, which we are referring to as group 3. And group 13 or 3, such as boron, has 3 valence electrons. And all the way over to chlorine, which is in group 7, has 7 valence electrons. And then the inert gases or noble gases, which have 8. We are not going to deal with those because those have a full shell of 8 and are considered stable, so they don't like to join with other elements. So the ones that we are concerned with right now are 1 through 7, excluding the transitional elements at this time. These are a transfer of electrons, and they are called ionic bonds. They are very strong, and that's because you have a positive and a negative attraction, plus the overall effect is a very stable element. So to give you an idea of how this works and how oxidation works, when you find the valence electron, for instance, if you find sodium's easy. It is in group 1, so it has one valence electron. You have to ask yourself, does it want to keep that one or get rid of that one? And the answer to that question would be, it would want to get rid of it. It wants to lose it. And by losing it, what happens to sodium is it falls back down to the shell below it, which has a group of 8 already. So in order to get stable, for some elements, it's easier to lose an electron, and that's what sodium's going to do. Because it's losing an electron, which is a negative charge, that creates an ion, which is going to be a positive, and that's because there's more protons now. Remember, all elements on the periodic table start off as a neutral element, so once that changes, it's either going to be positive or negative at that point. So if I just pull up a chart here, just to give you an idea, I'm going to use cards, and so sodium has one electron in its outer shell to give to chlorine, and when it gives it, okay, it becomes a +1. Now, over at chlorine, if you find out what group it's in group 7. So group 7 is going to want to gain an electron, and by gaining that electron, it gains a negative charge. So, but it's only gaining 1 in this case because that's all it needs from sodium, and it now becomes a -1. And that's because it has that negative extra electron. Now, since +1 and -1, when you add them up, goes to 0, the overall compound now has a 0 net charge, which means it's balanced, and that's what we want. So the new formula for Na and Cl, when joined together, becomes NaCl. NaCl. Okay, and that's a fairly easy one. You guys should be familiar with that one. Now, I guess the question is what happens when an element joins with another element when the ratio is not the same? Well, I have this scenario for you. Okay, here is lithium. Lithium is in group 1, and it's going to want to give away an electron. And when it gives it away, again, it becomes a +1. And it's going to want to give it away to this. However, oxygen is in group 6. So you don't want to have the oxidation number is not the group number or how many valence electrons are in the atom. It's how many it needs to get to 8. So in this case, oxygen needs 2 because it's at 6 already, but it needs 2 to get to 8. And when it gains those electrons, it's going to be a negative. So we say this is a -2. So as you can see, +1 and -2, when added together, don't equal 0. So we don't have a balanced equation, nor do we have a net charge of 0. So how do we fix this? What we do is we find a common factor. The common factor between 1 and 2 is 2. And in this case, in order to get this 1 to a 2, we're going to need another one of these. So how do we get that? Well, if we find another atom of lithium, we put it on here. And now we have 2 of them. So now this number is going to be not just a +1. It's going to be upgraded to a +2. And that's because we added a second lithium. And so when +2 and -2 get to 0, together, they make 0. And then this new formula becomes Li. How many lithiums do we have? 2. We put that number right there. And then we put an O after it. And the name becomes lithium oxide, because oxygen's name gets changed to an IDE form. Just like in sodium chloride, we had the element chlorine, which now changed to chloride. So IDE endings are used to change these. Yep. Come on.
I just want to let you know I'm going down to the thing at 2.
Ah, okay. That's all right. I'm on live. It's all right.
Oh, you're on live?
Yeah. I've got to cut out of it.
See ya.
Yep.